So continuing with 1.5, this is 1.5b as in boy in elementary algebra, and we are on example 7 on page 51, and we're going to just keep going here. And remember, I had mentioned that when we have a fraction, we do as much as we can in the numerator and the denominator before we do any division. Okay, so this one here, we're going to do what's on top. On the bottom, obviously, is going to be left at 12. So PEMDAS, in fact, I'm going to redo this so that it doesn't erase with everything else. Okay, so we do our multiplication first. Get a negative 6 plus 4. Alright, so negative 6 plus 4, the biggest number is a negative, and then the signs are different, so I take the difference and I put it over 12. Now, is there a way to reduce 2 over 12? Does anything go into both 2 and 12? Yes, 2 goes into 2, and 2 goes into 12. So we get negative 2 divided by 2 is 1, 12 divided by 2 is 6. Alright, so let's go ahead and keep going here. Part B says 5 times negative 4 plus 6 times negative 1 all over 2 times 3 minus 4 times 1. Alright, so let's do on the numerator first. So 5 times negative 4 is negative 20. Plus 6 times negative 1 is negative 6. On the bottom, 2 times 3 is 6, minus 4 times 1 is 4. Okay, so we're going to make that into a plus negative parenthesis so that we're adding. And let's do the top. So signs are the same, and the sign on the biggest number is negative. So when the signs are the same, you add. The bottom, the biggest number is positive. Signs are different, so we take the difference. Okay, and then we reduce. Is there something that goes into both 26 and 2? Well, the only thing that works is 2. So negative 26 divided by 2. We have one negative and one positive. Signs are different, so our answer is negative. And down here, we just have 2 divided by 2 is 1, so we get negative 13 for our answer. Okay, so the book doesn't teach this right here. I'm assuming they're going to teach it later, but I think it's necessary for you to know this. When we are taking a number and squaring it, one of the things that's important to realize is that we're only squaring the number. We're not squaring the negative. So the negative isn't even applied to this. So we just take 7 squared, which is 49. So we get negative 49. Now, if we put that negative in a parenthesis with the 7 and squared it, now we are squaring the negative. So 2 negatives give us a positive 49. Okay, so in this first one, this says 7 squared and then take the opposite. This says let's take negative 7 and square it. So negative 7 times negative 7. Very, very important to know the difference. You will make mistakes with that down the road, so just make yourself aware that it's there. So example 8. Alright, so we're going to square first, exponents. We're going to do that first. Okay, so notice I didn't square the negative 3. I just squared 3 and put the negative on there. Alright, this here, signs are the biggest number is negative, signs are different, so I take the difference. So 25 minus 9 is 16 over negative 2. And when I divide that out, 16 divided by 2 is 8, and the biggest number is positive, so I'm sorry, I'm thinking of something else here. The 16 is positive, the bottom number is negative. A positive and a negative give you a negative in division and multiplication. Does not work in addition, and that's the direction I was going when I made that mistake there. Alright, let's keep going here. B, 3 plus 2, and we're squaring it, and we're going to put it over negative 3 squared minus 2 squared. All right, so we do what's in the parentheses first. Okay. All right, so we have 25 over, what is negative 3 squared? It's going to be negative 9, because again, they're not in parentheses like that to give us positive 9. So we square the 3 and then we put the negative on. We do the same thing with the 2. Square it and put the negative on. So now I have 25 over negative 9, and I'm going to change it to plus negative 4. And that gives me 25 over, largest number is negative, 9 and 4 are both the same sign, so we add those, and we get 25 over negative 13, or if you remember, we can just write it as that as well. So either way works for you here. Alright, so we're going to continue on translating words into symbols. So if we're talking about multiplication, and it's a story problem or something, multiplication uses the word product. Product is the answer to a multiplication problem, just like difference is the answer to subtraction, and sum is the definition or is the answer for an addition. Quotient is the answer to a division. The ratio of A to B is a division. Ratio means A divided by B. A into B looks like that, or, it looks like that. Okay, so the top number just says, or the bottom number is written so that you're saying that it is going into that. Okay, so this says B goes into A. I know it's A looks like it should be said first, but the bottom number goes into the top. So if this were 10 over 5, that says 5 goes into 10 twice. Alright, so let's jump up to division by zeros. And I get students that do this all the time. And if you continue on with math and you get into calculus, you start doing some of these where you have 0 in the denominator because it's necessary for what you're doing. But anytime you have a 0 in the denominator, it is undefined. It does not exist. It is not 0, because 0 is a number on the number line. It's undefined. Another way of writing undefined is a 0 with a line through it, which is the null set. Okay, the null set, undefined, or that, whenever you have 0 in the denominator. Now, if you have 0 in the numerator, that's okay, because that equals 0. Okay? And they go into the y's. Most of students don't really care why. So let's just jump down into the applications here. And I think, we'll be done in just a few minutes. If you look at the bottom of page 53, Figure 1 gives the calories that are burned in 1 hour for a variety of exercise by a person weighing 150 pounds. Figure 2 gives the calories that are consumed by eating some popular fast foods. I'm going to put the picture of that on the screen here. Okay, so there's the drawing here. So Figure 2 gives the calories that are consumed by eating some popular fast foods. Find the net change in calories for a 150-pound person playing handball for 2 hours and then eating a Whopper. So he played handball for 2 hours. Okay, so 680 per hour. So that would give the total amount of calories burned there. And then after he burned those calories, he went and ate a Whopper. He ate 630 calories. So 1360 is how many he burned, but then he ate 630 calories. So that means that this guy burned 1360, so we do negative because those are calories that went away, and then he added 630. Okay, see what happened there? See why this is negative? Because those are the calories that went away, that left. So we have a largest number is negative. and then the signs are different, so we take the difference between the two. And there's the amount of total calories that he ended up losing because he filled up some of those with eating a Whopper. All right, so let's go into one more part and then we'll call it good. And this last part is called geometric sequences. Now in the last lesson we talked about arithmetic sequences, and arithmetic sequences were when we went, there's an N supposed to be in there, when we went, alright, arithmetic was 1, and then we went to 3, and then 5, and then 7. So we added 2 to each number to get the next number. Geometric sequences are similar, only instead of adding a number, we multiply. So let's say we have 1, and then 2, and then 4, and then 8. So what does that mean? That means to get from 1 to 2, we multiplied by 2. 2 to 4, we multiplied by 2. 4 to 8, we multiplied by 2. Okay, that's the difference between geometric and arithmetic. Geometric is you multiply to get the next number. So, what do I do if I get 2, 6, 18, 54? What's the next number? Well, I multiplied by 3 there, 3 there, 3 there, multiply by 3 there, and I get 162. Okay? That's all there is to geometric sequences. Okay, so let's look at some of the homework here, and I'm going to jump way ahead here. I'm going to look at number 91, so I'm going to pause as I write that down. Okay, so let's hope I wrote it down correctly. We're going to use PEMDAS a lot in these problems. So we're going to do what's in the parentheses first. So here's our first set of parentheses. But then we've got these little mini parentheses here within there. So we're going to do those first and leave the brackets alone for right now. So negative 3 minus 1. I'm just going to go ahead and put that in parentheses and not really do anything yet. Just make them plus negative 3. Alright, so 8 minus 6, brace 2, and negative 3 plus negative 1. Largest number is negative, the signs are the same, so we're going to add 4. Negative 2 plus negative 3. Largest number is negative, the signs are the same, we're going to add. Okay, so now we're going to continue doing what's inside those braces there. So I'm going to multiply those, because remember, that's the next step after we did what's in the parentheses. And 4 times negative 5, I put a plus there. Well, I'm going to leave that. Plus, that's what that is. 4 times negative 5 is negative 20. I'm going to do what's right here. 8 minus 6, brace, negative 8 plus negative 20. The largest number is negative. Signs are the same, so I'm going to add. Okay. Now all I have to do is, well, PEMDAS says we're going to continue multiplying, and this 6 is being multiplied there. So 8 minus 6 times 28. So 6 times 30 is 180, minus 12 is 168. Alright, so now I have 8 minus 168, and I can write that as 8 plus negative 168. Signs are, the largest number has a negative sign on it. Signs are different, so I take the difference between the two, and I'm done. Okay, so these can be really filled with a lot of opportunity for making errors. So really work at paying attention to what you're doing. We're going to just try one more here in just a few seconds that I have. 20 divided by 4 times 5. Now PEMDAS says that you do the multiplication and division from left to right in whatever order it comes in. So that is going to be negative 5 times 5 is going to give me negative 25. So we did that first, and then we multiplied.